Hi, we're Team 16. Welcome to our video presentation for Systems Engineering 1. I'm Christos.
Hi, I'm Jonny.
Hi, I'm Lim, and we are presenting to you our proof of concept for HydraChat.
Okay.
Hi, welcome to our video presentation for the Comp 2013 Systems Engineering module. So, what is HydraChat? HydraChat is aptly named after the multi-headed monster that Hercules killed. The concept originates from an idea that Bill Buxton had in the 1990s to produce a multi-person video conferencing application where each person within the conference is individually represented by a piece of hardware called a Hydra unit, which contains the audio and video feed for each participant. Isn't this similar to Skype or Uvu? No, we are not making another Skype. Unlike Skype, HydraChat will not use the typical split screen setup showing the feeds from multiple participants on one single screen. The photos of the original Hydra concept show that each participant doesn't need to be physically present at a meeting, as they can stream their audio and video to a singular Hydra unit, which has a camera, monitor, and audio speaker. The objective of Bill Buxton's original Hydra unit was to make a more lifelike solution for video conferencing. As each of the meeting's participants is represented on a device, it has the added benefits of being able to make proper eye contact with each of the participants by looking directly at their Hydra unit. Each person's voice is emitted from a different location, as the devices are placed round a table like a normal meeting. This gives a more realistic perception of human voices in a physical meeting. This allows for the spatial cues of being able to lean into one of the Hydra units and start a parallel conversation, or even pass a note to one participant. Our main objective is to create a HydraChat solution which does not require the use of the proprietary Hydra units. This will allow for cross-platform compatibility and easy portability. Imagine if any laptop, smartphone or tablet can become a Hydra unit. Before we could progress to the development phase of the proof of concept, as part of our planning we used the Moscow requirements technique to form a list of requirements and rank them as must have, should have, could have, and would have. This is important as it helps us form a list of requirements and then determine the scope of our project based on achieving all of the must-have requirements and striving to achieve all of the should-have requirements. The requirements shown on this slide refer to the high-level fundamentals of video conferencing, which requires the real-time transmission of participants' audio and video, then specifying that the system should function for between 2 to 4 participants. And obviously, the inclusion of a requirement that the stream of each participant must be spread across a device per person. We built this using the WebRTC API, which is open source software for real-time communication built by Google. It makes use of the mentioned JavaScript APIs to stream audio and video. We had to set up our own server to allow this to be hosted in an online environment. The diagram on the slide shows the peer-to-peer nature of the technology. The server is only required for signaling and setting up a conference. In this slide, we see the homepage for HydraChat accessible online. After the user gives permission for the browser to pull their camera and audio feed, this is displayed on the home page. From here, the user has the ability to create a new conference. On this image, we can see a live demonstration of a two-person call, labeled with all the features, namely a status bar showing which conference you are in and a link to share it with participants you wish to invite. You can see the phone containers which show what the individual Hydra device will be displaying. Hi there, we're doing a demonstration for our video, for our systems engineering module.
Hello. Hi.
Can both of you hear me as well?
Yeah.
Yeah, I can see both feeds from the video, and this is in a live web environment. As you can see on the screen, there's two phone graphics, which will eventually be split onto an individual Hydra device for each participant of the conference. After researching multiple APIs and working with a failed implementation of both the Asterisk and QuickBlock services, we were able to achieve the following with the simple WebRTC library. To make a realistic assessment of our achievements to date, we must cross-reference our progress against our initial high-level objectives. Our prototype is adept at transmitting the video feeds of online participants. The prototype has been tested with the defined range of number of participants. The only remaining requirement which needs to be fulfilled is the segmentation of each participant across separate Hydra devices. The heavy lifting code that is required to fulfill this will be completed in the second term Systems Engineering 2 module. As mentioned in the previous slide, there is the outstanding requirement of separating the feeds across multiple devices, which marks the bulk of our planned development. To achieve this, we will have to alter the protocols of the library with our own proprietary logic to make sure that we correctly assign the feeds to each of the separate Hydra-esque devices. However, WebRTC has opened a plethora of possibilities for us, as this is made of numerous sub-JavaScript libraries which all boast interesting functionality. We will be exploring these for the rest of our planned development time to implement the spatial cues such as parallel conversations. Once we have achieved this, we will begin to improve the cross-platform consistency of our service until we have a market-ready product. Thank you for watching our video presentation. See you later, guys.
See ya. Right, see ya.